All right, so welcome to part two. Part two, we look at a question that will require us to reinterpret the information into a diagram, but it is the same idea. All right, so the question reads, the frustrum of a square-based pyramid. So this is a pyramid with a square base, has the following dimensions. Each side of the square base is 5 centimeters. So there is a square base, and each side of the square base is 5 centimeters. So we'll start with the square base. So do that. So this is the square base. Okay. That, and this side of this square base is 5 centimeters long. Okay, so that is the first thing that we need to put into consideration. So this is 5 centimeters, 5 centimeters, 5 centimeters, 5 centimeters. All right, then each side of the cross section area, so the part from which it was cut from, is 3 centimeters. So let me just draw it nicely here. So it would be something like that. Let me see, can I draw it on top here? All right. Okay, so this is the cross-section part. My drawings are not that bad, can I? Okay. All right. So we have which each length is 3 centimeters, 3 centimeters. That we're dealing with. So now we are asked to calculate the volume of this frustrum. So now, after interpreting the information like that, what you are left to do is just solving the problem. So you do this if you were doing an interpretation question on cones and so on and so forth. All right, so let's start. Oh, we've also been given the height. All right, so the height of this frustrum, the height of this frustrum is 4 centimeters. 4 centimeters. So as always, as we said, first of all, we need to try to make the original shape of this, how the original shape might have looked like. So the original shape might have been something like this. It's a pyramid like that. Okay. It was a pyramid like that. Should be somewhere here. So it should have been like that. Let me just... So this might have been the original pyramid, and the green line represents where it was cut off from. So the bottom part is the frustrum. So again, we need to find the volume of this entire solid. Then from the volume of this entire solid, we remove the volume of the top part. So if we remove the volume of the top part, what we're going to remain with is the volume of the frustrum. So we find the volume of the entire prism. Then from the volume of the entire prism, we subtract the volume of the part that was cut off. Then we remain with the volume of the frustrum. All right, so what we have is after this shape was cut, it had a height of 4 centimeters. Okay, 4 centimeters. Okay, and where it was cut from here, this length was it was 3 centimeters from each side. Okay, so in other words, so we have this top part which we don't know the height of. So we're going to call this x. Let me change the color. We don't know this height x. So but the total height of this prism is equals to 4 plus x. Okay, that's the total height, which is the height in red here. Remember, we need to find the area, the volume of this entire, then we subtract the volume of that. So the height of this entire prism, pyramid, was x plus 4. Okay, again we use relations. Okay, this height is related to any of the bases at the end. So you can pick this side or that side. So we say this height is related to the base at the bottom. So we're saying height, this height, which is 4 plus x, 4 plus x, is related or is directly proportional to the height, to the length at the base there, which is 5. Okay, and this x is related to, hope you can see where I'm pointing. Let me just put up my pointer there. So we're saying this height is related to the height at the base there. Okay, so we say height is related to the height at the base there. So we say, and this height is x plus 4. So we say x plus 4 is related to the base at the bottom there. Then we also say x, which is the height here, will be related to the base there, which is the part where it was cut from. So this base is 3. Okay, so we say, so this is 3, so x is related to 3. So again here we cross multiply, so it will be x times 5, which will give us 5x. Then we say equal to 3 times 4, which is 12, plus 3 times x, which is 3x. So we make we group the like terms. This 3x comes this side. We're going to have 5x minus 3x equals to 12. Okay, of which x will be equal to 5 minus 3, it is 2x. 2x is equals to 12. We divide throughout by 2. We see that x is equal to, let me just move the entire page. Okay, see that x is equal to 6. So this is our x is 6. And now what is our h? Our h is equals to 4 plus x. So 4 plus x, which is 4 plus 6, which is giving us 10. So our h is equal to 10. So now we have everything that we need. So volume of the original shape, okay, will be equals to base area times the height. Okay, the base area, we are finding the area of this cube here. Okay, so it will be the area of this cube here. I think I should rewrite everything. Let me redraw the diagrams. So I have just written out the dimensions. So the original pyramid had height of 10. So this is the original pyramid, which is x plus 4 as we instructed here. So the original height was 10. We have a base of 5 centimeters from the question here. See that the base is 5 centimeters. Okay, then there is the top part that was cut. It was cut from a point where the base was 3 centimeters, so that's why we are having 3 centimeters here. And x, which is the height of which the part that we don't know, is 6 centimeters. So from here we just find the volume of this part and we find the volume of that. Then from the volume of this we subtract the volume of that, then we are done. So volume, remember, volume is equals to base area times height. Use red pen. Volume is equal to the base area of this. This is we have a square. How do you find area of a square? It is length times breadth. So now these lengths are equal, so it will be just this 5 times the other 5 that is there. So L times B, which is L squared, which is just 5 times 5, length times breadth. Okay, so now since they are the same, we say 5 times 5. Okay, so this is the length times breadth, so 5 times 5 times the height, which is 10. So the volume of this one, which is 250 centimeter cubed. So that will be the volume of entire. Then we come to this again. So again here the volume is base area times height. So volume will be equals to the base area times the height. The base area again, so this is base area, the area at the bottom here. We see that this is a square, so area of a square, just like here we did this times that. Even here area of a square is just this side times that side. Okay, so even for bases that are rectangle, we just do the same. Okay, yeah, so that is that. Then which is 3 times 3, 3 times 3, so 3 times 3, and the height is 6. So which is 3 times 3, it is 9. 9 times 6, that is 63. 63 centimeters. Now to find the volume of the frustrum, we just, from this we subtract that. So our final volume now, volume of the frustrum will be equal to, so you need to say volume of the frustrum will be equals to 250 minus 63, which will give you 250 minus 63, and that will be our final volume. So we put the units that we were counting with, that is centimeters cubed. All right, so this is how you approach volumes. So now for prisms, let's say if it had a square, let's say a triangular base, you know how to find area of a triangle, okay? But most of the times they will bring a square base or a rectangular base, okay? Yeah, so let me just run through what we did. Let me just run through what we did to find after interpreting the question, we drew out how the origin, okay, so this is the original shape, how it might have looked like, and we assumed the original shape had a certain height which we called h, and our goal was to find that height, the height of the original shape. What was the height of the original shape, which is h? Then after that, we just use ratios and proportions to find the height of the original shape. We say this height is related to this base because this is the entire base, and this height, which is x, is related to the base there. So we just do proportions. So we say h, which is which is x plus 4, x plus 4 or 4 plus x is equals to 5. Then this x is equals to that. When we simplify, we get our x equals to 6 there. Okay, then from there, all right, so this is yes, so this is the continuation of that. Then from there we write out the height of the original base. We just replace with x. H is 4 plus x there, and so on and so forth. H is 10, we replace 10 there. The base is 5. Same applies to this one. We have 3 centimeters as the base where it was cut from, then the x, which is 6. Then we calculate the volumes and subtract. So that is it. See you in the next lesson.